Hello, hi Shankar, how are you?
I'm good. How are you?
I'm doing well.
Great.
Firstly, let's start off with how was your Saturday?
Okay. Pretty good. Going as usual as any day.
Mm-hmm.
Yeah. So being in IISc, every day is the same day for us. Work, work, work. That's it.
So, okay, for audience who don't know you already,
Right.
how do you describe yourself in like four-line answer?
Okay. So I have three facets. Okay. So I'm a mechanical engineer from bachelor's. Then I did my master's in design. Right now, I'm doing my PhD in the area of what I like to call as X-ray developer. And in fact, for the audience, this is a word that I have coined. So X-ray developer. Okay. Later down the line, I'll tell you what it is.
Interesting. So you got me interested already.
Yeah,
Okay,
sure.
it's X-ray developer. Cool. We'll come to that.
Yeah,
But firstly, let's get into what we were supposed to talk today, right? Like we
sure.
discussed. So our agenda today is to break down manufacturing from basics for anybody who does not
Right,
understand
right.
manufacturing at all, right?
Perfect.
Completely from a technical background, I have no idea about what manufacturing means. Where do we get started? How are assembly pipelines done? Like no idea at all. So let's get started from a very beginning. What is manufacturing?
Okay. So manufacturing is nothing but cooking. Like
Okay.
like how our mom or ourselves we do it in kitchen. Okay. It's like converting the raw products into something consumable. That's all manufacturing is. Like in a cooking, you have raw vegetables, right? Which goes through a process, right? You do some heating or cooling or something else, and there are some utensils, tools involved. Uh, there is a person who is cooking that, so a human labor is involved, and finally it turns into a form which is consumable by the human beings. The same thing, the formal definition of manufacturing says that conversion of raw materials into finished goods using tools, human labor, and processes.
Okay,
That's
that
it.
was such a Google answer.
Yeah, but you have to keep it like, remind whenever manufacturing comes into your mind, think about cooking. That's all.
Cool. So you say it's from raw product, I mean raw materials to your end product. That's what
Finished product.
manufacturing is.
Exactly.
Okay. Let us go through some basic steps when we are talking. Okay, in this case, let's primarily address the industrial manufacturing bit.
Right.
I think these are different segments altogether, right? Like different kinds of manufacturing and
Right.
stuff.
Right.
So in this, let's probably focus on the industrial manufacturing side,
Perfect.
because our audience would probably be interested in the same
Yes.
thing as well. Okay, so when I talk about industrial manufacturing, probably let's take one example, one product per se,
Okay.
and can we go through the different processes that goes through for like this one specific?
Definitely, yeah. So before getting into the specific product, I like to start with the general overview of any manufacturing industry, right? How do they do this? So generally, any product goes through two stages: product design stage, product development stage. Okay. Product design has its own sub stages, right? It starts from need identification. What does the customer want? What does my end user want? First, then it goes through ideation, right? The engineers and designers in the manufacturing or industry, right, they come together and find out, okay, this is what customer wants, how can I provide them? That is the second stage, ideation. The third stage is about concept generation, right? So I have some idea, how do I realize and bring it into the real world? I can have an idea about a flying car, but is it realizable? Does the customer really would buy, right? So concept generation. Then you do something like testing, right? So you develop the concepts, you test it. So before testing, you have prototyping, and then on the prototype, you do some testing and confirm that, okay, this is the rough prototype that I'll convert it into a actual aesthetically pleasing finished product. So these five steps is what is product design is. The product development is where actual manufacturing comes into play. So which in other words you can also call as manufacturing, product development or manufacturing, right? It goes through the stages of fabrication, assembly, testing, verification, production, and finally quality and inspection before getting it into the customer. So these are the stages. Let's take the example of an automobile, right? How it starts, right? So some company, let's say Tata, since we are in Tata Institute, I'll take Tata Cars as an example. So Tata Cars, say the company decides to launch a new product into the market, new car, completely, totally, right? First, what they would do is they would decide for whom am I making this product. uh, is it for the younger generation? Is it for the older generation? Or is it for our office going people? right? So based on that, their style, their taste, everything changes, and that taste and style has to be reflected in the final product. A younger generation these days would look like a more classy, stylish product, whereas older people would like comfort more compared to style. Okay, depending on that, they would identify what segment of customer am I targeting. From there, there is a group of people in an industry, automobile industry, called designers, who sit down with their pen and paper and start sketching rough sketches about how this car should look like, right? What will be my end car, right? Like how we would scribble in a paper, right? That's pretty much what a designer does. He starts scribbling about how this car would look like. Then from there, from those sketches are then converted into prototypes using clay models and papers,
Clay
cardboards.
models?
Exactly. Yeah.
Oh,
So
actual clay is what you're talking
actual
about?
clay,
Okay.
actual clay. Literally, they use actual clay to make the full-scale car model. Actually, entirely it is built with clay. There are specialist clay modelers who are getting paid very high, actually, for doing that actual clay models. And from those clay model, it is then digitized using what we call as 3D scanning, and it gets converted into a computer model. Okay, so from that computer model, they do some engineering works on what should be the overall dimension, how should it be the tolerance, and some technicalities are there into realizing full scale actual working, right? Where do I put the engine, where should the brakes come, what color it should be, all those computerized things like what you see in an animation movies, right? So those things goes into play, and finally that computer model, using that computer model, they make an actual prototype, only one car, or a very few, 10 at max of 10 cars they do, and they test it for different things: crash test, impact test, side load test, different sort. They put the car inside the water and check how is it, how can a person quickly come out of the car in case it is submerged. This kind of testing goes through all these stages till this testing, what I'm talking about, comprises of product design. Okay.
Okay, so one quick question here. When we say when we talk about design, is it the same engineering design we're talking about?
Right.
Those
So
drawings that we used to do?
that comes at the later stage. Actually, those engineering drawings which we draw as a part of engineering graphics, almost every engineer would have
Correct.
studied in that, right? That's the end product of product design stage.
Okay.
With that designs, with that drawings, actually, in fact, they're called drawings. Those engineering drawings are the input for the manufacturing.
Understood. So that's like a final stage of your designs.
Final stage of the design is the engineering drawings. After all these testings on the prototype has been conducted, those drawings are taken to the manufacturing, and they decide what manufacturing process should I use for different components, because a car consists of thousands of components, right? Each and everything cannot be made in a single manufacturing, right? They diversify to different industries, and each of them manufactures only one part. There will be an industry which manufactures only bolts and nuts. There'll be someone who manufactures engines, brakes, gears, a lot of outside chassis, body, so many things. Once that is done, they bring them together. So all these are called fabrication, right? Once all the parts are fabricated, they bring them together into what is called as an assembly line. We have to put them together, right? So it's like making, attaching parts with each other and creating the overall assembly. Once assembly is done, then quality and control. You have to inspect whether all the parts are right, because when you make in thousands, quantity in thousands and 10,000s, there are chances something might go wrong, right? It's important that everything must be verified that it's perfect to the mark. So that's quality and inspection. Once that is done, they do a couple of other validations, like government norms and things will be there. You have to make sure compliances will be there. You have to check that. Once that is done, then they release it into the market. So this will comprise the second half of the product development stage.
Got it. So so briefly put it together. When you say fabrication is done, fabrication is more like individual parts are tested.
Individual parts are actually made from raw materials. That is actually the manufacturing
or sourced.
It can be
made or sourced. Exactly. And then we assemble all of them together on an assembly line.
Yes.
Then we push it through quality control to check if it's working or not.
Yes.
But this, after quality control, is going to be direct production, or are we going to have any testing
We have
stages?
a couple of small testing stages at the end, actually. They randomly select few cars and ask drivers to drive it continuously for 100 kilometers, 200 kilometers, or even for 2 days continuously. See how it works. Is it as intended as what we designed? That also comes as a part of validation and verification.
Understood. So, okay, this was very interesting example for us to think about, right? But how do you think manufacturing has evolved over years?
Okay. The entire manufacturing has gone through 4 stages of evolution, right? We call it industry 1.0, 2.0, 3.0. We are currently in 4.0, and within a couple of years, we are going to migrate to 5.0. Okay. 1.0 started at 18th century when steam engines were discovered, when actually the steam engines were used in the manufacturing floor to actually automate some processes. So steam engine was the first discovery in the industry 1.0, which changed the whole way in which manufacturing works. The second is the late 19th century when electricity was discovered, when motors came into play, which changed the whole way in how the products are manufactured, where products were started to be manufactured in mass productions. The concept of assembly line came in the second industry 2.0. Then came during the late 20th century, from after 1950s or 1960s, if I have to say, where the concept of digitalization, digital systems, computers came into play. Digital systems came into play. Microprocessors, microcontrollers, transistors, diodes, electronic circuits took over. So this would be the third industrial revolution. After 2000 or 2005, which is the industrial revolution 4.0, where we call this industry 4.0 is a smart system. Okay, so smart system is where the use of robots came into play. IoT, Internet of Things, cloud computing, all these things came into play. Soon we are going to migrate into industry 5.0, which is called as intelligent system. So if we have to see the last three industrial revolutions, it is from digital systems to smart systems to intelligent systems. So just to put a clarity here, the difference between smart and intelligent is, smart is when you make the machines are made to make decisions, right, based on predefined rules. Whereas intelligence is when the machines are made to make decisions on the go, right? Let's say there is a mission where you have written a predefined set of rules, right? If this happens, do this. If this happens, do this. Okay. But there might be a case when something will happen which is not written in the rule. So the machine doesn't know what to do. That is smart system, what we call a smart manufacturing. Okay. Whereas the other case, intelligent system, is where there is rules as well, but even when there is a case which is not even written, which the machine doesn't even know beforehand, but still it will be able to adapt to the new situation and make decision similar to what a human would have done at that point in time, right? So an example would be use of artificial intelligence, right? Artificial general intelligence. That will be the case of and most importantly, the use of extended reality systems, right? This would be the industry 5.0, which we are very much nearing. In another couple of years, we would full on get into this.
Okay. So a few quick questions here that I have. From smart manufacturing standpoint, that's industry 4.2.
Yes.
What I understand is when we are talking about manufacturing, there are predefined rules. Okay, let's say you have industry 3.0 where people used to do a lot of things, right? Which we kind of try to trim it down or make it more efficient by bringing in more machines, coding and saying, okay, these are like step 1, 2, 3, 4, 5 that needs to be done.
Yes.
Please take a call and work on it. So that's your 4.0.
Yes.
But when I'm talking about 5.0, what would those edge cases be where the system should take control? Or is it safe? Like,
okay, so safety is an aspect that really needs to be discussed. But in fact, a lot of people have started using Industry 5.0, using artificial intelligence into their everyday system in the whole manufacturing line as well.
Like, for example?
For example, so starting from when a part is getting manufactured, okay, so I need to do quality testing, right? I need to check for various things. Is the dimension correct, right? How do I do that, right? I will have a range within which, okay, if the part lies within this range to this range, okay, then it is correct. Okay, that's a predefined rule, okay? But there are times when it might not be the case. Let's say the part is misaligned, okay? While checking in a smart system, they will check, okay, the dimension did not align within this range, okay? Whereas in an intelligent system will understand that no, it is correct, but the part has been oriented to a different position, and that is why the dimension is wrong. I will correct it automatically. That decision on the go is made by an intelligent system, where a smart system won't be able to identify it.
But what is the degree of accuracy we are looking at the moment, like whenever 5.0 is being used?
If I have to put a number, I have to guess somewhere in the range of 90 to 95% we are there. The last 5% mile mark, I'm sure will cross.
Understood. Okay, so this was like, it took me on a different tangent altogether,
Okay,
right?
okay.
That's interesting. While the next question I would probably have is, okay, you answered my question about how technology would play a role in manufacturing anyway. And we've also heard about something called a supply chain.
Yes.
Where does supply chain fit into your manufacturing?
Okay. So supply chain is a fancy word for saying logistics, right? Let's say a car is manufactured, right? What are the raw materials that you would require for a car to be manufactured?
Metal.
Metals. You mean a lot of minerals, metals, lithium for the batteries, and petrol for the fuel and all these things. Most importantly, metals. Almost majority of the car is made up of metal, one or the other metal. Okay, so where are these metals from? They are from some mines somewhere, right? So some people is mining those metals and they are taking it out, right? Starting from that point, that metal has to reach somewhere in order to form tubes and blocks, some raw form, okay, some standard shapes. From that standard shape, it has to get to an industry where that standard shapes are converted into shape which I want, in which I can fit in the car, right? So throughout this entire process, starting from mining the material till the end stage of getting it into the customer's hand, how are different materials transferred from one place to other place? I should say a path, right? Description of a flow chart about how materials are being transferred, how the semi-finished goods are transferred within different industries, finally to the customer. This entire flow chain, it's a chain, right? It's connected by one after the other. This entire chain is what is called a supply chain.
Okay, so can I just call it as project management for manufacturing unit?
Okay.
I mean,
Yeah.
Is that what it's similar to?
Right, something like that. But there are a little bit advanced techniques, but you could put it in that way.
Okay, understood. And also there is this concept of sustainability that we are hearing everywhere, right?
Yes.
So,
yes.
And the only thing that I remember when I'm talking about sustainability is that during engineering, we had something called lathe, which we were supposed to make. And like, okay, there is metal dust. You can use this dust for different purposes and stuff like that. That's my understanding of what manufacturing or how do you save raw materials comes from, sustainability standpoint.
Right.
But today, when we are talking about sustainability within manufacturing units, where all does sustainability come into picture and where it's primarily being used right now? Or maybe what is the scope in the future?
Perfect. So in order to answer the question, I'll answer one more thing. It's about what are the major challenges that industry is facing with all these advancements that we have. Technology is at our hand actually. With a few years back, 2020 and after COVID, ChatGPT revolutionized the whole world, right? So similar to that, we have so much technology in our hand, but still there are, I would like to put it in this way that a manufacturing industry faces three important challenges. Okay, first is how can I make a sustainable product? That's where sustainability comes into play.
Sorry, to cut you off. When we say sustainability here, is it sustainability of the product itself, or?
I'll give you an explanation in a minute. Okay, so just remember the word that there is something sustainability which is affecting the industry. It is a challenge to the industry.
Understood.
Okay, the second is about security. Okay, so the thought of theft, right? Stealing your product and making copies of it, right? So we know that iPhone is made by Apple, but as similar to as good as an iPhone, there are very cheap products which looks indistinguishable from an iPhone, but it's a cheap product, right? So the cyber security, that's the second aspect which is a major challenge in an industry these days. Okay, and third most important challenge is about automation, right? Automation to every industry. Okay, I'll come back to this point, but I would like to answer you on the sustainability part. Lot of people confuse sustainability with something associated with greenery, right? Biodegradable. These are words that are misused in a lot of terms. I would like to put sustainability on a clarity in this way, right? Take it and put it back without affecting the environment. That's all sustainability is. Take it and put it back without affecting the environment. Let's say, okay, I'll take the example of this watch. In order to make this watch, materials were taken from the earth. That is, take it, right? And those materials were processed by numerous processes. right? Chemical processes were going on, right? And finally, this finished product is there. I'll be maybe using it for another 2 years or so, right? After that, what happens, right? If it doesn't work, or even if I like a newer model, I'll just throw it away. Where do I throw it, right? I throw it in the garbage, or it just goes somewhere, right? Where does it go, right? If it ends in a landfill, is it affecting the environment? One is about after the end of a life, or after a product is being, let's say it doesn't work, right? There is some problem, you throw it away, right? After you throw it away, does it affect the environment? That's one thing. And during the manufacture, starting from acquiring the raw materials to the finished product, it goes through various processes. Does any of those process release harmful things that affects the environment? Sustainability is about making something sustainable, is about taking the raw material to the finished product, and even after life of the finished product, in the entire journey, it should not affect the environment. How can I make such a product? That's it. It has nothing. I mean, there are things that has to do something with greenery and biodegradable, but it's not only the aspect of sustainability. Okay, can I reuse it in some way? Can I modify it in some way so that it doesn't end in a landfill somewhere? At the same time, it is reusable, right? Reduce, reuse, and recycle. These are the three words that you have to keep in mind when it comes to sustainability.
What is your favorite product, or favorite sustainable product that you've seen that's been manufactured?
Okay, so these days, even big hotels, they are adopting from going to their utensils, right? They are changing it to a way where I found one interesting product on having consumable utensils. I have a plate, I have a cup, I have a spoon, I have a fork.
Is
I
it like
eat
a
with
wafer?
it. Something like that. Something like
Uh-huh.
that. There is this guy, I forgot his name, but he pitched it in Shark Tank, and
I remember, yes.
I liked it. I think if it comes to market, what better could there be? We use plastic plates, plastic jugs, plastic water bottles every now and then, right? And imagine you drink, you eat, and then you consume the same thing, and that's all done, right? It's a beautiful way of putting sustainable manufacturing.
That's interesting. I've been asking you a lot of random questions about manufacturing, right? What is a common misconception that you've heard about manufacturing in general?
Right. Okay. See, always manufacturing is associated with mechanical engineering. I don't know, for some reason, when you say mechanical engineering, that's where manufacturing. It is not actually.
Okay.
Given that industry 4.0 and 5.0 is coming into play, no longer mechanical engineer are the only person who will be doing manufacturing. Okay. So the four misconceptions which I usually hear from a lot of people is that first one is, it is very tedious.
Isn't it tedious? Come on, there's a lot of steps.
No, I'll tell you what I mean. The tedious for a person, if you study that, you have to get your hands dirty. It's not a white collar job that way. Tedious for in that way. Okay. Not at all. Not at all. No long. See, there was a time when human beings were standing on the shop floor and doing the manufacturing, operating the machines all by themselves. That days are long gone. Okay. So hereafter, everything is about automation, right? The person who will be in charge of manufacturing will be sitting in an AC room, monitoring and controlling the machines rather than getting his hands dirty down the line. Okay.
But what is the degree of this adoption? Is it already happening?
It has happened to a large scale, large level. In fact, we are right now in IISc, right? 2 kilometers from here is Pina, right? There are so 3 levels of industries are there: large scale industry, medium and small scale industry, right? There was a time when automation was only in large scale industry, right? Right now, this automation has occupied till small scale industry. If you go to Pina, you can find a lot of small scale industry adopting automated machines and
Sorry,
robots.
when you say automation, what kind of automation would they be adopting?
Automation.
One small product.
Okay,
example.
so let's say let's take the example of this water bottle, right? There is this water bottle is made by a manufacturing process called injection molding, right? There was a time when you have to stand in front of, it's very hot, the injection molding, the temperature at which it is made is very hot. You have to stand in front of the injection molding machine. You have to manually put the material in. It'll create this water bottle. Then you have to take it. A human has to be there, right? Right now it's not there. There are automated injection molding machines which automatically takes you have to feed the raw material from a big tank, right? It automatically goes into the machine. With a pre-default time, it will automatically create this water bottle and push it out. That's all. No human has to be standing there. There is a computer which does all these things. The only responsibility for a human being is to make sure that the computer is working properly, right? He has to sit in a room, monitor everything. That's an example of an automated injection molding machine. Similar way, all the missions that are used in manufacturing have been automated to a level that even the small scale industry have come in. Oh, I'm sorry. What was the question? Misconception. So that was the first misconception where people say that yeah, it is very tedious job. No longer. The second thing is manufacturing is not for women. Right? There was a time when I studied mechanical. It was full of boys. No girls were there in the class. Okay, so no longer it is that way. So manufacturing has so much become a transdisciplinary scenario. You need people from electronics. You need people from computer science to program. So computers is doing the job, right? I need someone to operate the computer, right? I need people to put the machine together, right? I need mechanical people. I need someone from design background, right? All of them have to work in cohort, right, to get the job done. So a mechanical engineer no longer has to only study mechanical. He also has to know programming. Programming is kind of become mandatory for everyone these days, right? So that's the second thing. And so women, no longer you can't say that women are women cannot study mechanical or women cannot do manufacturing. No, it's a total misconception. Days are changing slowly, and you people can come in. That's the second thing. So the third thing about a misconception about manufacturing is that it's very difficult, right? It's very difficult. It involves a lot of mathematics, too much complications that you cannot understand, right? Not at all, right? No. Right. If I have to put in a very simple way, you have to understand manufacturing from the standpoint of mathematics. In mathematics, there are 4 basic operations. Okay, that's how manufacturing itself is. The entire manufacturing I can classify into 4 categories, right? The 4 operations are addition, subtraction, multiplication, and division. And all the manufacturing process can be brought down into these 4 categories: additive manufacturing, subtractive manufacturing, multiplicative manufacturing, and divisive manufacturing. One example would be the water bottle, which I have in hand. This is made using a manufacturing process called injection molding, which is an example of multiplicative manufacturing. What does multiplication do? Let's say 2 into 4. The answer is suddenly 8. You don't do 2 plus 2 plus 2 plus 2 plus 2, right? Within an instant you get the answer. The same way, the raw material goes into the machine. Within a fraction of a second, this bottle is made. That's multiplicative manufacturing. Any manufacturing process that converts the raw material to a finished product within a fraction of a second, that's a multiplicative manufacturing. And traditionally, majority of the other products that we use are made using subtractive manufacturing. It can be thought about something like a person who is chiseling the rock to make a statue, right? You have a whole rock, you remove part by part, small materials slowly, and you finally the end product that you want, the shape that you want evolves. Lathe machine, drilling machine, shaping machines, these are examples for subtractive, where you have a large block of metal, you slowly remove material, and finally a shape evolves what you want.
By the way, good question. That you mentioned lathe. Do we still use the same machine that we use for lathe, or is there something that is happening in
exactly.
that field?
So lathe is still there. You cannot replace lathe, but it has gone through a automation. It has got itself married with computers and turned itself into CNC lathe. Computer
CNC.
numerical control the lathe machines.
Okay. Right? So we no longer have to stand in front of.
Not at all. Not at all.
I'm very glad about that.
Yeah. So.
Okay. But can you give me some examples on the different types of manufacturing that you mentioned? It was quite interesting, right?
Exactly.
For divisive.
Multiplicative. This is multiplicative.
But for division and.
I'll give you. Okay. So the second is subtractive manufacturing. Let's take this metal. Right, this is made use of a subtractive manufacturing process. So we have a large chunk of metal. I slowly put in a lathe and start removing chunk by chunk, and finally I get the finished product. So this can be an example of subtractive. Additive manufacturing is that it's an opposite of subtraction. Addition, what we'll do, we'll take small pieces and add them. So this is an example of an additive manufactured part. It's a lattice structure where layer by layer, small material, micron level materials are slowly added one by one above the other to construct this entire part. So 3D printing is a commercial name for additive manufacturing. Okay, so in itself that it has a lot of other classifications, but if you have to understand materials are being added, then it is additive manufacturing. 3D printing is an example of that. So these are the 3 primary categories: additive manufacturing, subtractive manufacturing, and multiplicative manufacturing. And divisive manufacturing, I would like to call divisive manufacturing as mom's cooking. Right, that's actually divisive manufacturing. In practicality, in actual scenario, there is no such thing as divisive manufacturing, but I would like to think of it this way, where a food industry uses divisive manufacturing. What does division do? 8 divided by 2 is equal to 4. Okay, which means 4 is a proportion. 2 proportions of 4 makes up 8. Raw material, I take proportion of this vegetable to proportion of this vegetable, together put forms the final proportion. So food industry is an example of where you can think about manufacturing as a divisive manufacturing. But other than that, majority of the other industries use additive, subtractive or multiplicative. So the order in which it comes is subtractive first, multiplicative second, subtractive first, multiplicative second, additive third and divisive fourth.